type them into the calculator successfully, how to see the graph, and then see these questions that I asked you down here. You might not know all of these things, but I'm just going to show you on number 1 what they mean, and maybe you can pull them out of like number 2, number 3. Does everyone have a calculator at their area? You got a calculator in there? Yeah. Everyone has a graphing calculator near them? You have one? Okay. You did graphing calculator. Okay. And then something to write with is everyone has this packet now? The rest of you were here yesterday, right? So this is page, what did I say, 201. So it just says graph each function, answer the questions that follow. My hint is you have to put parentheses around your numerator and denominator. So when you type this into the y equals menu, the x plus 3 in the numerator needs to be in a parentheses, and 8x minus 4 of the denominator needs to be in parentheses. So let's type that together into our y equals menu. So x plus 3 in parentheses divided by x minus 4 in parentheses. I like to hit zoom 6 first, but then yes, after we do this one, you can just hit graph. So it should look like this if you got it typed in correctly and you did zoom 6 to get a 10 by 10 viewing window. Did anyone not get those elbows to show up? Rational functions, you're gonna see these elbows. So we have to figure out like which quadrant, do they go like this and like this, or is it like a volcano graph where they're both pointing downward? So rational functions are gonna look like this. They're gonna have elbows in a couple locations. Zoom 6. Do you not see that right now? Is it zoomed out too far? If you hit zoom 6, you have to put it in the y equals menu. You did that, right? Okay, but from now on, I can just push graph, and now because I'm on a 10 by 10 viewing window, I can see that. So now it's kind of hard for us to tell what the intercepts are. So if you want to just estimate, but I can find the x-intercept by going into the table. So like second table setup, yeah, if I just go like 1 and 1. So I should be able to see where my x-intercept is. See how it's at -3, 0 in my table? I could kind of tell in my graph it happened somewhere over here at like -2 or -3 or -4. It's hard to tell. But it does happen at -3, and it's kind of hard to tell where that y-intercept happens. Maybe you would estimate it happens at -1. It actually happens at -3/4, but we don't really know how to do that yet. So I mean, you can kind of estimate like, all right, it's happening here and here. We might not be sure why yet, but we're just kind of sketching what it looks like. Just a rough sketch. And for now, we really don't know kind of all these pieces of information. I was able to find that the x-intercept is exactly at -3, How could I find the y-intercept? From an equation, what can we plug into an equation, any equation, to find a y-intercept? You had to do this on your quadratics. 0 for the x's. If I plug in 0 for the x's, what is my output going to be? 3 in the numerator, -4 in the denominator, so -3/4. See how that y-intercept is right around -3/4? So your x and y intercept, I think you should be able to figure out from the just sketching the graph off of here. What is a vertical asymptote? So a vertical asymptote is a place on the graph where both of those elbows are coming closer to each other. So this is actually a vertical asymptote, and this is actually a vertical asymptote. See how I can kind of cross my graph and it's getting closer? You might not know what that is right now. We don't have a way right now to figure out what that value is or what that value is. This one is a lot more complicated. You could actually figure the vertical one out if you wanted to. What x value will make your denominator be 0? 4. Can you divide something by 0? No. So that's why this is a vertical line at 4. because that would make the denominator undefined. So if you feel uncomfortable right now figuring out these vertical and horizontal asymptotes, that's what we're going to spend the end of the week doing. So for now, if you just want to kind of plug them in and sketch what they look like, and at least find maybe the x and y intercept, let's do one more together. So let's look at number 2 together on this graph. So I'd have x in the numerator. So I'm going to go back to my y equals, clear out what's in there, divide by parentheses x plus 4. Maybe you can start to predict something like, what's this one going to look like? What is its x-intercept or y-intercept going to be? Because we're going to come up with rules for how to graph them by hand. So here's what this one looks like. So you can kind of draw a rough sketch. What does it look like the y-intercept is this time? So where is it crossing right here on the x-axis and y-axis? We can check. If I plug in 0 for my x's, what would I get? I would get 0 divided by 4. What is 0 divided by 4? 0. So my x and y intercept is actually 0, 0 for this problem. And then just kind of draw a rough sketch. We don't know exactly what our asymptotes are. Just a rough sketch. See how that's just rough sketch? I knew it went through 0, 0. I don't really know my asymptotes right now. Maybe some of you could look at the function and decide, what does this vertical line have to be? Where would the denominator be 0? Like what would I plug in for x that would make, right, so this vertical line is actually at -4. But we're going to learn that later. So for now, go through, graph it, sketch the graph, even if you don't know the asymptotes, but try to find your x and y intercepts at least. And then we can come back and review this maybe like the end of the week. What would the vertical asymptote actually be? So there's 8 of them total. So see if you can do the other 6 problems, sketching them. And then if we have time, we're going to go back and look at some of that factoring circuit as well. But I want you to do this exploration first.